So we'll start with the midterm. So the first problem in the midterm was load the weather set, right? So if you have done assignment 2, okay, this was one of the tasks as to how to load the weather set, okay? So it gives you the path where the weather data set is available here. If you see assignment 2 solution, it's posted on Talent LMS, okay? And then it also gives you a website, a blog where they have discussed about weather data set, okay? If you go to this site, right, there's a lot of information about this weather data set, okay? You see here. So it's, if you go, what I do here is very easy. Can you see my screen? Let me increase my font a little bit. Let's see how I can do that. View, font, zoom in. Okay, wait. Let's see. It's trying to increase the font size. Let's see if it works. Okay, so I was showing while it works. So the first part, it says a weather read.csv, right? And instead of, you can do either, you can give the file name, or you can specify the website, okay, the Dropbox location. And Dropbox location was given here. Sorry, in the assignment 2 solution. In assignment 2 solution, the location was for the weather data set is given, and it said that you have to set DL equal to 1. Okay, so if I go there, can you see my screen?
Yes.
Okay, very clear. It's very clear, right? So if I say weather equal to read.csv, okay, and I give the path, okay, what was given on the assignment 2 solution here, right? And you have to just change DL equal to 1. It says here also that you have to say, if you want to view it, DL equal to 0, but when you want to download it, you have to set DL equal to 1. So if I set DL equal to 1, then I run this part. Let's run this part, and if I do run, okay, and now let me see, it's loading weather right now here. Okay, now let's see summary. I can see summary weather.
सर वो स्टार्ट हो गया है. हाँ 7 o'clock अर्ली हो गया. उनको भी बता दीजिएगा, सौरभ सर को.
Okay, so I'm running summary weather. It will download the weather read.csv will download it, and then it will run. So I think right now it's still downloading. That's why it's taking time. Okay, you see it came back, right? Summary weather came back, all right? And then if I want to see what are the columns in weather, I can see names, weather. It will give me, oh, sorry. And I was saying that you can go to this blog which was mentioned, and it gives you a lot of information. Like by doing DIM weather, it gives you dimensions, which is how many rows and columns are there in the weather. So if you see names weather, it shows all the columns, all the information which is there in the weather data set. All right. And if we do dim weather, it will tell you how many columns and rows, so row and column. So 365 rows and 14 columns. Okay, and if I say if I want to view some information, we can do head or tail of weather. It will give head will give top 5 or 6 rows. You can set the number of rows you want to see. There's a setting. So right, so this gives you some information on weather, like what is the day of the month, uh, day count, that number of days since the beginning of the year, uh, what is the month, season, what was the temperature, right? So it's winter, temperature is more than 12 degrees centigrade. What is the average temperature of this month? What is the temperature? What is the time? What is the rain average? So rain, average wind, gust wind, gust wind time, wind direction. So it gives you information about some information about the uh, weather. Okay, so that's the data set. Any question on the first part on loading the data?
Sir, suppose I want to see 10 different records. So in that case, we have to give head within bracket weather, comma 10.
Yeah, so we can check, right? So it's easy. I don't remember all these things, but it's very easy, right? If you say head, question mark, and it will give you the information on that function.
Okay.
Yeah. Are other people joining from?
Okay, sir, we have given a message on WhatsApp.
Okay. Okay.
Just now I called them, sir. Just now I called them, so they are going to log on. Actually, they were thinking that the session is going to start at 8 o'clock.
Right. So I sent a mail, and then I sent a on
Facebook also.
On Facebook as well, right? Yeah. So
Yes.
I'll continue. I'll show. We'll discuss few things here, and we'll wait for them to join. Okay, before we go further. Okay. So here, right? It's very easy in R, right? That you don't have to remember everything, right? What is important in R is to understand what R can do. Okay, and then the rest of the stuff you can very easily by going through the manual, you can find it out, right? So now I see head, right? So let's see. If I want 10, let's see how I can do it. So it says probably it means that n equal to, if I give 10, probably it should print 10 records, okay? Look, it's printed 10 records. You see,
Right.
Jyotirmay, you were asking, right? So, or Ajay. So, yeah, so we can get 10 records because it say n equal to, you pass on the variable what you want, right? Let's say I want to find the bottom records, right? Not from the top. So I can say tail. Instead of head, I want to see last 10 records. I can do tail, and it should print the bottom records. And you can see the day count. And that's where you know that these are the last 10 records because the day count starts from 356 to 365, right? Month is 12. And here the month was 1. So here we are looking at the first 10 days of the year, and here we are looking at the last 10 days of the year, right? So this is how you can use head and tail to see your get some idea of the data. And again, summary is a very useful function, right? So you can always try using summary to see what your data looks like. I just want to ask you, are you familiar with what this min, first QU, median, mean, third QU, max is showing you?
Yes, it is clear.
Okay,
First
yeah.
quarter, second quarter, yes.
Yeah, so this is the minimum value of the data. Okay, so it's very clear from month that first month is the minimum quartile, is the minimum point. First quartile, it's saying that 1/4 of the data is less than fourth. Okay, half of the data is less than 7, half of the data is more than 7, right? Mean is 6.5. Okay, third quartile is 10, right? So 1/4 of the data is more than 10. So 10, 11, 12. So that is how it's been done here. Same for temperature. So this information is useful for identifying outliers, right? So your first quartile and the third quartile should be pretty much equidistant from the median if the data is normally distributed, right? And then you can look at where is the minimum value and where is the maximum value. If the maximum value here is 200, it's too far away from 16. Then you may want to look at plot that data point, and you want to check that what's happening with that. Okay. Right. last time you had question on R square, right? I just want to go back and want to check with you that do you have any more understanding of R square, that what R square is? Any of you, Jyotirmay or Ajay? Uh, I can quickly, while we are waiting, I'll wait for 5-10 minutes more, 5 minutes more for if other people are joining. Otherwise, the recording is there. They can watch the recording. So I will try looking at R square. Lecture notes on linear regression. Here it is. Okay, so can you see this chart, this scatter plot?
Yes.
Okay, so if you see this scatter plot, right, we can see that as the value of x is increasing, right, the value of y is also increasing, right?
Yeah.
You can see as x is -4, the value of y is closer to -10. As we go to around 0, the average value of y is also 0. As we go to x equal to 4, average value of y is around 10, correct? So
Right.
with increase in x, there is an increase in y, right? So the trend is very clear that x and y are positively correlated, right? Now, let's say if we have to, given a value of x, okay, given a value of x, you are asked to predict the value of y. What will be the value of y? Okay. How can you do that, right? One thing is that if we know what all values of y were there, right, you can say that the best guess is the average value of y. You do not look at the value of x at all, okay? You say that the average value of y will be, let's say, looks like around 2 here, right? You take all the values from -10 to +20 and divide by the number of data points, right? So it will come somewhere around 2 or 3 here, right? So you get that number as 3. So far clear? If I get a line, it will be 3, right? And you draw a line 3 of 3 going from -4 all the way to +4 or 5, whatever is the scale here, okay? Take the distance from this line 4 to each data point. Let's say this number is -11, right? So 4 to -11 is a distance of 15, okay? So you measure the distance of -15, square it, it becomes 225. Take the next data point, it is 14. So you take the distance, this is 9, and let's say your score is 40, here 4. 4 to 9 is 4 to -9 is a distance of 13. So you square it, it becomes 169, and so on. You sum all the data points from your mean value, okay, and then divide by the number of data points, right? That is we call is the maximum possible error you can have with a dumb model, a model which just uses mean irrespective of what the value of x is. Okay, that is called total sum of squares, TSS. Okay, total sum of squares. Why? Because we are taking squares from median, from mean to each data point, squaring it and summing it up. So total sum of squares is this value from your mean line to each data point. Okay, Ajay, Jyotirmay, Rohit, right? Okay.
Yes, sir.
Now let's say that we know that there is a trend, right, by looking at it. So if we fit linear regression, regression will say that, okay, at each point of x, you don't have to use same value. Okay, it will say that you use some intercept plus a beta times x. A beta times x may be 2 times x. Let's say the beta comes out to be 2, right? So the value of y is -2 plus 2 times x. Okay, so now if I get a value of -2 plus 2 times x, so if I plug in a value of -4, okay, so -4 times 2 is -8, and I add an intercept term of -2, which becomes it -10. Okay, so then this point at 4, my model will give a value of -10. At -2, it will give a value of -2 times 2 -4, an intercept of -2 -6, somewhere here. At 0, it will give a value of -2. At 4, it will give a value of 8 and -2, 6, right? So this model line, if we start drawing the model line by plugging in each small values of x, each value of x, the line will now go from a sloping line. There will be a positive slope of the line, right? Which will go from, let's say, -10 or whatever value comes at value at -5, it will be value will be -12, because 5 times -2, sorry, -5 times 2 is -10, and intercept of -2, so -12. -12 it will go up like this, right? Now, if I take this line, okay, and from this line, if I take distance to each data point, right, it will be much smaller. Do you agree? Because the line is going much closer to each data point now because it is sloping. Whereas the first line was just a straight line. At every data point of x, the value was 2. Okay, so if I have this line, at every point it is saying 2, and then if I am taking a distance for each point, it will be much bigger compared to a line which is passing through each data point. Okay.
Sir, how you calculated this beta value?
Okay, so that is a linear regression, right? That will show. Okay, so there's a function called linear model, LM.
Okay.
That
Okay,
will
okay.
give. So the difference is that in calculus, you know the function, okay, and you get, and for every x, you plug in the value of x in the function, and you get a value of y. Agreed? We know sine x, we know x square, right? So function y is x square, and you know the function which is x square. You plug in the value of x, you get a value of y. In regression, the difference is you know the value of y, you know the value of x. Now you have to come up with a function, this linear function, okay? And what is the objective of getting this linear function? That from the given value of x and y, I estimate my linear function. So now when I have given a value of x in future, I can predict the value of what the value of y will be from this function. So that's the objective of linear regression. Okay.
Okay.
So we
So
will
one
show.
variable we have to keep constant, and another we are supposed to find the value.
Correct. Right. Yes. So now in future, you will be given only the value of x, you will come across the value of x, and you will be given, you have to predict the value of y. For example, right?
Yes.
We have historical data of weather, right? So that when the wind speed is this one, the wind direction is this, wind speed is y, if we have a temperature of z, right? How much rain happened that time? Okay, so if we go historically, we have this information from meteorological department, right? That every time when it rained, what was the humidity, what was the wind direction, what was the wind speed, and what was the temperature. Okay, now with this, our objective is, can we find some relationship between rain and these variables? Okay, so now what happens next? We will say that now we can estimate that if the wind is going to come from southwest direction, and if the temperature is 50 degrees centigrade, what kind of rain can we expect? Okay, so that gives you a function, prediction function. Or if we have certain situations, okay, in the society, like if the pollution goes up, what will the number of tuberculosis problem can happen in the country, right? And that is very important for health department, because then they can see that okay, it is very important to spend money over here, because as the pollution increases, we can assume that this is the example of level of pollution of particulate matter in the air, and Y is the cases of tuberculosis, right? So once we estimate this function, someone who is in the government, they will have a good idea that okay, how uh, how difficult this is going to be, how serious this problem is. Okay. Okay. So as I said, that we will show you how to estimate this through linear regression. Okay. So now, as I was saying, that this the error which you will get for each point by having this line which is predicted by linear regression is much smaller. Correct. So now so that is why this is a measure of R square, that what was your original error and how much is the error now left, okay, by fitting this line. Okay, so how much error has been reduced, okay, how much error was in the beginning, how much error is left, you take the difference of the two, and now it shows that by using the model, how much error has it been reduced. So that is R square, that's a measure of R square. Okay, percentage of variance explained is R square. Okay,
So is
I
it,
go go ahead.
I mean, root mean square error is similar to this R square?
Okay, so root mean square is like root mean square velocity or root mean square terms which we use. It is a similar concept because okay, so root mean square it's different. Okay, root mean square is from each data point you take the observed value, you square it and take a square root. Okay, so what I computed the total sum of the square, right? That is similar to root mean square. Yes, and then RSS is also similar to that, right? That from each data point you are taking the error which is now there because of this sloping line, and then you take the difference of the two. Okay, so if you take TSS, what was the total sum of the square? Now you subtract what is left, residual sum of the square. Okay, now and divide by the original total sum of the square. That ratio is R square. Okay, R square is the difference between what was the error when you had no model versus what is the error now left, what is explained. Okay, that is the residual sum of square. If your R, if your function is such that it goes through each data point, okay, then no error will be left. Okay, let's assume that these data points were on a straight line. Okay, they were not scattered, right? Then linear regression will be able to find a line which fits through all the data points. Agreed? If it's just on a straight line, y equal to x kind of a line, right? It can find a beta of 1 or 2, and from that line, if you take a distance to each data point, it will be 0. Everything will be 0 because every data point is on the line. So residual sum of a square will become 0. So your model explained, after fitting your model, there is no more error. So TSS will be whatever value minus RSS becomes 0 divided by TSS. So it will become 1. And that means that your model has 100% explanation, which doesn't happen. So, okay. All right. So we can go back to the midterm. So I was showing the first part, which was load the weather data set. It's very easy. I was talking to other guys. The assignment looks very difficult midterm, but it's not. I tried doing it myself last night, and I was able to do it like in 2 hours. Okay, so it's not very difficult. So the first part, load the weather set. If you go to the assignment to solution, okay, assignment to solution is here. Assignment to solution, right? So the first part was pretty much given in assignment to solution. You can see it gives the weather data set. It can be found here. You set DL equal to 1, and that gives you the that's how you will download the data, and it gives you the method also for downloading from a file and from a website. Okay, and this is what, and if you go to this website, it gives you a lot of information about this data set. Okay. So on our studio, if you just copy this command, okay, and run it, it will download the weather data set. Okay, I did it here, it ran, and it downloaded the weather data set. And then you can do summary and you can see dimension. It has 365 rows and 14 columns. Okay. Any question on this? It's very simple.
Can you
Second
increase
part.
the font size? Can you
Okay.
increase the font? Control plus. You just press Control plus. I think it is going to work.
Okay, let's see.
Control plus plus.
Okay. Control
Plus. Control Shift plus.
Okay. Yeah. Is it better, or you want to increase it a bit more?
Yeah.
It's okay.
That's fine. Fine.
Okay. So this is how. This is what I ran. Okay, to do the first part. Okay. Second part. Second part was turn the season column into factor. Okay. Again, if you go to analytical blog, this discusses how to change a column into factors. You can see here, you can check the class. Okay. Also, if you want to check the class of all the variables, okay, it's a very simple function, lapply. Okay, lapply will apply a function to all the columns of your data set. So if you do lapply and class, it will apply class function on each column and it will show you the type of all the columns. Okay, so right now it says that season is character. You can see season is of type character. Okay, and we have to change it to type factor. Okay, so simple as this, as dot factor, and we can do weather, and we can dereference season here. Also, this website discusses how if you want to have a certain ordering, you can do that by specifying the levels. But in the problem, it did not ask you, so you can just simply do the season. And if I do it now again, lapply, let's see. So season is now a factor. Okay. Right. Now the next part asks you to write a function to turn all the character columns of a data set into factors, right? So you can do it two ways, right? I did a quick search on some Google and to see like how it could be done, to go through some websites and blogs people have posted a lot. So you can either do using for loop, okay, where in for loop you can go through each columns of your data frame and check for whether this data frame data column is of type character, and if it is type character, you can apply the same method as dot factor and that column, okay, and that will convert. The other simpler and more terse way of doing it is, as you know, lapply applies a function, okay, to all the columns which are passed. For example, we used lapply on one column, which applied lapply on all the columns of weather here, right? But let's say there's something called sapply, okay? So sapply, let's see what sapply does, okay? Let me run sapply. I did sapply and said whether comma is character, right? What it is doing, it is checking whether what of the columns are of type is character, and it's returning false and true. Okay, so season was a character, but now we have already converted season to factor, it's false. But the other columns which were character, it's testing the condition and it's returning true. So it's staying true, temperature.time, gust.wind, gust.wind.time, direction.wind.time. So now it's telling me what are the columns where the type is of type character, right? So now I know is apply. Now on top of that, if I say weather, now from weather, I want the columns where the type is character. It will return me only those columns which are of type character. I should do head, I guess it will be better, right? So let's say if I do head, I think it will print me the only the first few. Look, okay, so I got only those columns which are of type character. Okay, so now I got this. Now to on top of this, I will say, okay, now L apply on this, and I can do is dot as factor, not is factor, I think as factor. Okay, okay, and then we have to assign it to as well, because now it did, but it has, we have to assign it. It had converted everything to levels. You can see it is converting to levels. So now you can assign the whole thing to the same set of columns. Okay, so this method will run this method. Sorry, what happened? Okay, so I am just muting everyone. Just a second. Okay. And now if I do I'll apply weather.class, you see all of these have converted to factor. Do you understand this function, how I try to build my function here? I think, can you mute your microphone if you have like some noise? I just don't want to mute everyone, so that way you can unmute when you have a question. So far, do you understand how what I did here by L apply S apply? Is it clear? The question was to convert all the columns of weather data frame which was of type character to factor. Okay. Next problem. The next problem is create a date column for the weather data set. Okay. Again, this is pretty straightforward. It's given in. Is it given here? Probably. Yes. We need a date. You read this blog and you get this answer as well. It was very simple. Okay. So what I did here, create a date, and it's also in the problem, it gives you a hint that you have to use sequence.date, right? And when you search for sequence.date, it gives you how to use this function. Okay, so the function it uses is you have to give the start date, okay, from where the date has to be started, whether you want to increment the date by number, by days, by weeks, by month, by year, okay, and how many data point do you need. Okay, so I created a new column called date. I started from the first date of any year. You can call it 2014, 2015, whatever you want. Increment by days because our data set has all day of the year. And how many number data points we need? I need as many data points as the number of rows in the weather data set. And if I run this, it will give you the, it will create this weather data. Okay, and now if I see head on weather, it will should have a date column as well. Okay, now if I do tail of weather, it will also have all the way till the end of the year. Okay, so it's straightforward. So you have to just focus, look at each problem and keep solving it. It's not difficult at all, as I was saying, right? So so far up to this point is very easy. Okay, now it says make a table of wind directions by season. Okay, and it's already given you the syntax for doing it. It's very simple. It's showing you what needs to be done to make a wind direction of time season. Okay, so now there's Nagresh has a question. Write a function to turn all the character columns of dataset into factors. It can can be done like this, whether read.csv, string as factors, yes, you can do strings as factors as true as well, correct, right. But probably it's better to just read everything as a string and then you can do it there, but yes, that's also one way of doing it. And as said, and then you can also do in a for loop as well. Just like any programming languages, you have multiple ways of doing the same thing. Okay. Make a table of wind direction by season. The answer is given here, and if I do this, weather wind direction by season, and if I run this, it gives you the creates a table and it gives you the frequency table. Okay, the table gives you the frequency of each occurrence, and it gives you this answer. Okay. Now, if I want to, you can sort as well. You can do whatever you want on this, right? If you want to just see that it asks you later that what is the most frequent wind direction, that could be done by applying a sort function on your weather. Okay. So you can. Okay, so let me go back to the problem. Okay, so whether it first asks you to print the wind direction by season. Okay, the frequency table of wind direction by season, and then it says you that using apply, okay, you need to find out for the entire year which wind direction was most common. Okay, so now it can, I think Adam wanted you to understand the apply function. Okay, that's why he gave you like this, but you can also do it simply that if you do sort and if you the table of wind direction by decreasing and don't break it down by season, it will give you the frequency table of all wind direction by year, and that tells you that northwest is the most frequent wind direction for that year. Okay. The other way is you can create this table which is by season. Okay. Then you sum it across each row. Okay, so this is what apply does. You are applying, one is by row, two is by column. So this is the same table, this part. One is saying it's by row. I want to sum up all the row elements. Okay, and if I do this, it should give me the similar output. If I do this, okay, but this is not sorted, so probably I may need to add a sort on top of this, I guess. And if I do decreasing equal to true this way, and let's print this run. Okay, so I get the same thing. So you see how you can split or decompose your wind direction by season, and then you can sum it up across the rows, and then you can sort it in the decreasing order, ascending order, and you can see that which is the most frequent occurring wind direction, and the answer is northwest. Okay, so far. Okay. Now it says that there are like 16 primary wind directions, 16 wind directions. Okay, and you have to change them by adding wind 4 column. Okay, you have to add one more column which is wind 4, and you have to aggregate these 16 wind directions into 4 primary wind directions: north, south, east, west. Again, this was given in this blog. So I did like last night. I went through this blog and saw how they have done it. So it's pretty simple, right? So you can look, you can check for the condition that if wind direction is in this, they have created 8 wind direction out of 16. Here you have to create 4 wind directions. So it is again very simple. You have to, by taking a help from that blog, you can write this code. First, you copy your current wind direction into wind 4 variable column, and then you have to check if wind direction is in any of the east wind direction, you call it a east. If it's any of the north direction, you call it north, south, and west. And so if we do run this, for example, let me do first run this first part, weather, wind direction. Okay, and then if I say unique weather $wind 4, what does it print? Okay, so it's printing all these wind directions because I have just copied the original direction.wind. But now if I run these conversions, which converts east to all the east to east, all the north to north, south to south, and west to west, if I run this, okay, now let's run the same thing, unique. Okay, so now you can see that it has just south, north, west, and east. Okay, so this is pretty straightforward. 7, create a table of wind 4 direction by season. Okay, so again, this is very simple. We already did this. So if you do this wind 4 by season, it will give you the frequency table of wind direction by season. So very straightforward. So I think till this point it was very easy. There was nothing which was difficult in this problem. In fact, like everything was there in this weather blog, which Adam gave the link in the second assignment. Let's look at the next problem. Next problem is create a basic ggplot bar plot for wind direction. You can look at your assignment 1 and you can do this, how to do the plot of bar plot and 8 and 9. So we'll not spend time on this. This is just you have to read bar plot, and it's good that you try reading a bit more on the bar plot and do this thing. Okay. Chi-square test, it's very simple. So do a chi-square. We did the chi-square test in assignment 2. The wind direction table is given. Okay. And it's asking you a couple of questions, which you have already you have done this kind of thing. So you have to run a simple chi-square test on the data set season and wind direction, right? So you have this table already. If by printing table weather season and weather wind direction, it will create this table for you, and then you need to run the wind direction. Okay, so this table will give, if you print just this table, right, what does it do? It gives you the direction of wind, the frequency of this wind directions by season. Okay, so what's the hypothesis? Hypothesis is that are these wind directions which are with this frequency, are they occurring by random chance? Okay, that they are coming from the same distribution, right? All these are coming from the same distribution, and that's what chi-square test will give you by giving the p-value. Okay, so again, this is pretty simple. You have done a chi-square. You will look at the output of chi-square, and you will provide your explanation that what you understand from the output of this test. So that part you have to do. I'm not giving you the answer for that, but you have to look at you have to understand what the hypothesis was for this test. How do you yeah, I think in this problem, like Adam has given, he is saying that just to see if wind direction is same in all seasons. Yeah, I think you can do it in on wind 4. Yes, you can do on either. It's more to test like you understand how to do chi-square. So Tejas is asking whether it's on wind direction or wind, which is 16 directions, or 4. Okay, you can do on either. Just you have to give what the hypothesis is and what's the whether you accept or reject the hypothesis that they all come from same distribution, right? So next part is create a linear model. Okay, again going back to Jyotirmay and Ajay, you were asking that how to come up with the betas, right? And how do we use linear regression? right? Some examples, right? So I can give you an example where I use linear regression on a daily basis, right? You know the stock market, right? So let's say in the stock market, based on the previous return, let's say if a stock, Infosys stock or Apple stock, in the last 5 days, it has some returns, right? Plus 10% return or minus 10% return. Can I predict the return on the next tomorrow or the next 4 days, 5 days by looking at the return on the past 5 days? Okay. For that, you may need a regression. Okay. You may create your regression function, which will tell you that, okay, now I know what was the return in the next last 5 days of Apple stock. Can I predict what will be the return going forward? Next example, if I know how much volume of Apple stock was traded in the last 5 days, using the volume, can I predict the return on the next 5 days? Okay, so for example, if I look at the standard deviation of Apple's return, right, can I say that the standard deviation of Apple stock return predicts the forward return of Apple stock, right? Or all three variables are important. The previous return, the volatility of return, and the volume of the stocks traded. The previous 5-day or previous 10-day values of these three variables predict the forward return, right? And for those things, you need to create a regression model. Okay. Now here in this example, uh, it is based on predicting rain. Okay. So the regression is based on contemporaneous variable, or it is based on lagged variables. All right. So contemporaneous variables regression is important for understanding phenomena. Okay. It's not important. It is not useful for predicting something, right? Because what I mean by saying contemporaneous means that you are measuring all the variables at the same time, right? So you're measuring that if the wind direction is northwest, if the temperature is 25 degrees centigrade, if the wind speed is 5 miles per hour, okay, I observed a rain of 10 centimeters, okay. Now you can, with contemporaneous, you can understand a phenomena that, okay, now whenever there will be high wind, whenever there will be a given range of temperature, and if we are in a given season, there's a possibility of getting into the rainy condition, or it will cause floods. So it is important for scientists or government organizations who are looking at like global warming, where they're saying that, okay, as the temperature will increase, I think we will have more flooding or something will happen, right? Or as the pollution level will increase, uh, the temperature will increase and it will create a problem, right? But when you want to predict, you always need lagged variables. You cannot use contemporaneous variables. What you really need is that if the wind direction is 5 miles per hour now, and if the temperature is 10 degrees centigrade and the humidity is 70%, what's the chances of having rain tomorrow or in the next 1 hour? And those variables are more useful for prediction. Do you get the idea of contemporaneous and prediction? So example, Tejas, you work in risk department, right? So risk management. So risk management is done more on contemporaneous variables. Regression using contemporaneous variables, and trading. When you do trading is done mostly on prediction. So the Barra models, all the Barra models, which gives you the stock risk decomposition, they run contemporaneous variables, regression. And anyone who is running statistical arbitrage kind of trading strategy, they do lagged regression. And the R square of contemporaneous regression is much higher compared to R square of lagged regression. Okay, it was I was just giving some context for Tejas. All right.
Thanks.
Okay, so we can go to the linear model now. Okay, so linear model is saying that given can we create a linear model to predict rain in terms of season, average temperature, rain, average wind, and wind 4. Okay, so what it is saying is that you create only a second data frame with having only those columns which are needed for this regression. So it's pretty simple. Again, it's you can look at the hint which is given. So if you say the names of weather, names whether it will give you the location of each data point. So season is number 4, so I want to keep number 4. Number 7 is temperature. I need temperature, so column number 7, 8, 9, 10 I need rain, 11 I need wind speed, and 16 I need wind 4. So I created a weather 2 with these columns. And if I say now names weather 2, now it has just only created a second data frame with only the columns I need for my regression. Okay, so I have what I need for my regression now. Now it says that create a regression model where your y variable, okay, the dependent variable will be rain, okay, and it will be regressed on all other variables of your weather 2 dataset, which is on season, temperature, wind speed, and wind direction. Okay, again you can check one more thing that you can say L apply before running regression on weather 2 comma class. It will give you that wind 4 is a character, season is a factor. Probably you may want to convert wind 4 also as a factor. So probably we may want to do L apply on wind 4. Let's see, whether dollar wind 4 will be L apply whether, I don't know R much, I'm doing it with you, so let's see, whether dollar wind 4 comma as dot factor. Let's see, now if I do L apply class, it did not do that. Wait a second, whether L apply whether, oh sorry, weather 2, sorry, weather 2. Now let's check I'll apply class. It has created it as factor. Wait, it's created a list with a factor. What? Okay, I think, give me a second. If I do okay, I think we have to create this weather wind 4 again, sorry. Okay, and then you have to apply it. You have to apply it as weather.wind4. I think I have messed up the weather 2 column as well. I think I have to start from here. Sorry. You have to do it here. This now again. Now will do this. Run. Okay, and now I have to do weather 2 as factor. Okay, now I'll see I'll apply weather 2 comma class. Okay, now it's factor. Okay, so now once you have created all your variable, either is numeric or factor, you can run the regression by simply calling this LM. LM is a linear model. Okay, and it's saying y, it's rain is the y variable, and everything else, it will be regressed on everything else on the data set which is weather 2. Okay, and you can keep the output in some object. Okay, and then you can run summary on that object to see the output. Okay, the summary of this object will give you the information on the intercept, on the all the coefficients, the p-value, f-stat, all the information is stored in this object. So now you have to look at this object, okay, and then you have to give what is the R square of the model, okay, and then you have to accept or reject some of the hypotheses, some of the coefficients, right? So by default, the null hypothesis is that all the coefficients are 0. Okay, null hypothesis is that there is no relationship between any of these independent variables, which are season, temperature, and wind speed, and wind direction, on the amount of rain. Okay, and then you know how to check for how to accept or reject this null hypothesis, so that you look at the p-values, you look at t-stat, and based on that you have to answer this question. Okay, it says that I do this way by looking at the median and mean residual. Again, when you print summary of this object, it will give you all the information. Okay, and also when it says that I look at the residual, you can plot the fitted value versus the predicted value, right? By, if you do this, it will plot the fitted value versus what was the dependent variable, what was the rain, what we were trying to predict, and what we have predicted. Okay, so you can take a look at this this output to see how good your fit was. Okay, if we look at this, then it seems that at the lower end and at the higher end, it's not doing pretty good job, right? Seems like it's more it's not linear. There's some kind of a bias here, right? So I mean, you have to give in your interpretation. There is no, as Adam has mentioned at the beginning, that there is it's vague, right? So there's no right or wrong answer. You have to just interpret and give the answer, whatever you want to. Okay. Question 13, confirm or change your conclusion by running a plot of the actual rain on x-axis compared to the predicted value. That's what I did here, exactly what I did here. Okay, so this, and then next step says that you have to run the model, but this time with no intercept. Okay, and just using season, temperature, and wind. So it has taken one variable out, which was, I think, wind direction, and it says a no intercept, right? So you can simply do this by specifying what all variables you want, and you can either you give +0 or you give -1. In both cases, it will take off the intercept. Okay, and then you save this object is rain.test.2, and you can do, if you do summary on rain.test.2, it will give you all the information which is needed. For example, I can show you. I run this and plot this, and it gives you all the information which are needed for you, this regression. Okay, so I think that is everything in midterm, right? And again, it's asking what are the variable coefficients for which one will accept the hypothesis that they are 0. Okay, and then you have to give your interpretation at which of the two models is better. Depends. It can be like, it can be as vague as that both models looks pretty similar and it's very hard to go for one versus the other, or it can be that, yeah, one model is definitely better than the other model. So I think that's pretty much on the midterm. I think I have answered all the questions. I've pretty much given the solution to all the questions. So you have to go back and spend some time here, try doing it, and then if you have any further question, you can write it to instructor@acats. The whole objective is, yeah, I'll upload the video, Nagresh. Yes. The whole objective is that you get an understanding of this. So you try doing some things and try. Okay, one thing which you will find it interesting is that in this regression, there are some numeric variables and some factors, right? The factors are the wind directions and season. And you have to look at how regression is using these factors, right? So one thing I want to emphasize, the reason why you may want to convert your the variables which are categorical into factors or categorical variables is because, let's say if I have a regression where we have a day of week, okay, and day of week, instead of given as Monday to from Sunday to Saturday, it's given as 1 to 7, right? And now if you just do a regression and pass this variable day of week, regression doesn't know that it's a categorical variable. From 1 to 7 you mean Sunday to Saturday, okay? It will assume that this is an increasing value, okay? And it will try to fit a regression function based on 1 to 7. But if you pass it on as a factor, it knows that, okay, I need to fit separate regressions on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? And it will try to fit 7 different parameters. That is the effect different from Monday to Tuesday, from Tuesday to Wednesday. Whereas if you pass it as just as a numeric or integer, it will try to see that, okay, Monday to Tuesday is an increment of 1. Is the effect also increases by the same amount, Tuesday to Wednesday, and so on. Okay, so try spending some time on categorical variables, at how it's used in regression by looking at the output. Okay, that's important. Other than that, I think everything else is already being discussed, and I'll upload the video, and you can, if you want, you can look at the solution again and then submit. Again, I'll unmute, and then if any other question, otherwise we can end the session now. Okay.
Hey Manish.
Yes.
Yeah, quick question. When we summarize the linear regression model, right? I need some understanding on how to interpret the residuals, right? The quartiles that we get. How, I mean, I'm having difficulty understanding how do we relate that in terms of overall result.
So here, for example, you have this one, right? Residuals, yes, minimum to maximum, right? So yes, it is saying that, okay, you fitted the model, okay? Yeah. Y versus X. Okay, let me go back to some model where it's very easy to show you the picture. I might have, go back. Give me 1 second, okay? I just want to get to a
sure,
some graphics so that it's easier to understand this thing. I think in this lecture on linear regression, lecture notes, yes, let's do this thing. Okay, so let's say I fit a line through this. Okay?
Yep.
Okay, so I'll have a slope of, let's say, beta equal to 3 or 2, whatever, right? Probably looks like 2.5. Okay, so I fit a beta of with a 2.5, and the line will be sloping upward with a beta of slope of 2.5, right? So now from each point, okay, if I from each data point and the value predicted by the line, right? So if I'm at 2, I will go to 2 times 2.5 times 2 will be 5. Okay, so I'll be somewhere in 5, right? But here at 2, there are like values which are at 14, or the value which are at like 7 or like 4, something, right? So for each of these points, I will compute what's the error from my model. Correct? Residual sum of error, right? So I'll compute these errors, right? So for each of these data points, right, I will have an error. Yeah. The error is what the real observation was and what my model predicted, right? Difference of the two, correct? Okay. So you have all the errors, right? So now once you take all the errors and you sort it from descending to ascending,
okay? I see.
So what was the worst negative error you predicted? What was the worst positive error you predicted? Okay.
Right. Okay.
And then what the mean should be 0, because that's what linear regression is doing. And that's why in the presence of outlier, the regression model is bad, because it takes care of outlier as well, right? Because it has to make the expectation of these errors to be 0. Expectation of all the errors from your fitted model, that expectation has to be 0. The mean has to be 0. So no matter what, if the output of regression from outputs of residual from regression model, and if you take the expectation or mean, it will always be 0, but not the median. Okay, so that is what it is showing you here, output, that the worst error which you made was -24. Okay, median error was -1.3, and the maximum error was 67. So this is what kind of errors you are getting from your model.
Right.
Okay.
I see. All right, thanks.
So this is a very good, like, people do not look at this, they just look at their final output, they just look at beta and use that. But I think it's important to look at that, how big errors are you making. If the errors are too big, it may indicate that you may have some big outliers, and you need to fix, you need to do data cleaning first, right? So also, before regression, it is important to look at your data, spend some time on plotting your data, okay, to make sure that you do not have some outliers which may inadvertently affect your regression coefficients, right? One technique for doing this for cleaning data is called winsorizing. Okay, it's used a lot by Barra regression framework, where you take that anything which is outside the 99th percentile confidence for each variables which I am doing in regression, I will set that value to 99th percentile. Okay, whatever is the 99th percentile value, anything above that will have the value of 99th percentile value. Anything which is below 1 percentile value will have a value of 1 percentile. So you are cutting the tails at 99th percentile and 1 percentile, but still retaining the data. Okay, you are not throwing the data, but you are setting the max and minimum value, cap and floor, and then you do regression.
Yeah. So is it fair that, like, once we have the residual information, and if we compare that to the actuals, let's say, we can see how bad or good the model is kind of fitting, right?
Correct. Yes. So if you plot the residuals, right, and if the residuals are forming a trend, right, that means that the model is not predicting things correctly, right? There is some other trend which is not being captured, right? As the value of your input variable is increasing, and then the residuals are increasing in dispersion, is increasing, then that's called heteroscedasticity, right? Okay, if a smaller value, you have a smaller dispersion, but as the value is going, the value of your input is increasing, and the y is and your prediction is residual is fanning out, that's not good. So those are the diagnostic plots which you may need to do to check the quality of regression. Okay, you can also see the fitted value versus the actual value. That also shows a kind of regression, right? It's showing that the regression when the rain was 0, my fitted value is showing that my regression is negative, right? Here, fitted value is giving that I predicted a negative rain, which is absurd, right? So it needs to be fixed, probably, right? When you look at these kind of things, you may think that, okay, I need to do something in my output that this cannot be 0, less than 0. Okay, I cannot say that negative rain, right? Also, on the other side, when the actual rain was a lot, right, you can see that 60 centimeter rain, but my fitted value is very small. It is in fact dropping here, right? So of course, the regression cannot give you everything, but it is capturing some effect, but it is not very good for sure.
Yeah, thank you.
All right.
Yeah, thanks, Manish. Okay,
any other question if you have, especially in regression or how it's used in industry, I can answer you. Okay, plots are important. Also, you do a lot of time you do regression on people talk about machine learning. Okay, machine learning is nothing but it's some form of regression. I can also make a regression instead of using all the data at once. Okay, I use only past 6 months of data. okay, and past 6 months of data, I keep predicting the next day and always using the rolling window, okay, and that becomes a machine learning technique. That what it's not, I'm not using a fixed value of beta for predicting, but my beta is changing with time. Every day I'm looking at the last 6 months and using the last 6 months of information, I am predicting the next day's value, right? So that's form of machine learning. So again, you need to get good at this before you start thinking of machine learning, because without knowing all these details, machine learning is useless. It's very easy for me to tell, like, okay, instead of LM, use the other function which gives you ridge regression, or another function which will give you lasso, okay? It will not take any effort. You may have still the same input data set, LM will get replaced by some other call, and you will get an object. But unless you understand how to interpret the residuals, how to interpret these coefficients, what are the factors, what are the categorical variables, unless you know the question beforehand, the answer is useless. You need to know the question. Okay. All right. So we end this session, and then Adam will have his class focusing more on R and R packages tomorrow. Okay. All right. Thank you.